Hi and welcome back to single phase transformers. We are next going to be using the Notorious 75 kVA transformer. Single phase, 600 down to 120, 240 volt secondary. Once again, we're going to determine the maximum primary overcurrent protection of this transformer. We're going to determine the minimum conductor size for the primary and secondary of this transformer. So by now, I'm sure you guys could do this in your sleep, but let's work with it. $75,000 VA divided by 600 volts. We have a current of how much? 125 amps. We then, of course, have to throw in the 25% safety factor here in accordance with Subrule 1. We then take 125 amps times 125%. And lo and behold, we come up with 156.25 amps. Now, they do not make a 156.25 amp overcurrent device, so considering that's the maximum, then we have to go down. So we have to go down to 150 amps is our maximum overcurrent device for this transformer. All right, just that easy. Next, we have to determine the minimum conductor size. So once again, we're going to work with the primary first. Once again, $75,000 VA divided by 240 volts. Oops, wrong. Too early in the morning. 600 volts. And once again, 125 amps. We throw in the safety factor of 125%. And lo and behold, we come up with 156.25 amps. That is our minimum primary conductor ampacity. Next, we're going to work on the secondary conductor ampacity. Now, 75,000 VA divided by 240 volts. And what do you come up with? Roughly 312.5 amps. Now what do we have to do with this? Multiply by 125%. And we come up with a grand total of 390.62 amps. All right, primary conductor size has to be at least 156.25. The secondary has to be at least 390.62. What table do we have to go to? Yeah, oh, I heard it. Table 2. What column? 75-degree column based on 4006, the 75-degree C. So 156.25 puts us up to the 2 watt. The 390, ooh, geez, we just missed the 500 because that is good only for 380 amps. We have to go up to 600 kc MIL. Now, a lot of times it's pretty tough to get 600 kc MIL, so we run parallel runs. So in this case, let's take our 390.2 and we're going to divide it by 2. Okay? And what do we come up with? 195.1? So we're going to run parallel conductors, so 2 runs. And take a look at 3/0. 3/0 is obviously less than 3/0 is good for 200 amps, which is obviously more than the 195.1. So wouldn't it be easier to run parallel runs of 3/0? So the 2 little lines there means 2 runs of 3/0. Anyway, so that concludes this 75 kVA transformer. Our maximum overcurrent protection is 150. The minimum conductor size is 2/0 copper on the primary. The secondary would be a 3 conductor 600 kc MIL if it was 1 conductor. However, if you decided to parallel it, it's parallel runs of 3/0. 3/0 is much easier to deal with than this nasty little guy. Anyway, thanks for watching, and when we come back, we'll be working with 3-phase transformers.